Hello students, welcome to my next online class. So this is the continuation video of the previous chapter, Archimedes principle, right? So watch the video till the end and don't forget to subscribe my channel to get the latest update. So you see, in this video we will see that what is principle of flotation and sinking. So when an object is immersed in a body, so the weight of the object is acting vertically in downward direction and a upthrust or the force is exerted by the liquid on the body. So this one we have learned in our previous class, right? So sometimes an object is seen, sometimes it sinks inside, sometimes it floats inside. So if you say what is the law of flotation or principle of flotation, here it states that when a body floats in a liquid, the weight of the floating body is equal to the weight of water displaced by it. That means if an object is immersed in a liquid, it will float only when its weight is equal to the displaced liquid in upward direction. Okay. So you see, whenever any object is immersed in a liquid, two forces are acting on that body. Now if I consider this duster, I am immersing in a beaker, right? So when I will immerse in a beaker, if the weight of this duster is acting in downward direction, if it is more than the upthrust exerted by the liquid, then the object will sink inside. But if I consider if the weight of this object is less than the upthrust exerted by the liquid on this object is more, that is upthrust is more, now weight is less. So definitely this will float on top of the liquid, right? So what are the two forces acting on an object when it is immersed in a liquid? So the two forces are, that is weight of the object and the upthrust exerted by the liquid on that particular object, right? So what are the two forces? The weight of the object, that is weight of the body W1, which acts vertically downwards at the center of gravity of the body. Whenever any object, you see any geometrical shape, the weight is said to be concentrated at the center. This center is considered to be a center of gravity. Like any object, if I consider this book or this diary, you see it is in a rectangular shape. Now if I need to balance this diary, I need to place my finger at its center. So this is the center of gravity. So if you place your finger here, then only you can balance the total weight of the object. In case if you put your finger here, then it will not rotate, right? So many of us have seen that we can rotate this object only when keep our finger at the center of gravity. Otherwise it is not. So what is center of gravity? It is the point at which the whole weight of that object is concentrated, right? So similarly, when an object is immersed in a body, so its weight or the center of the weight is acting at its center of gravity. So first force is center of gravity, weight of that object, and next the upthrust exerted by the body. So these are the two forces which is acting on an object when it is immersed in a liquid. So I have considered here three cases, that is case 1, case 2 and case 3, right? So this condition will be understood by this diagram. You see I have drawn one beaker here. So let us consider beaker is containing some liquid, let us consider water, right? Now I am immersing one object whose weight is W1 in this liquid. So when I am immersing this object, when I am putting this object inside that water, if the weight of this object is more than the upthrust exerted by the liquid, then the object will sink. That means object will come here, right? So this is the object, that is W1. So why? Because W1 is greater than W2. Now we can prove this one, right? You see, so W1 means m1g, weight means mass into gravity, acceleration due to gravity. Now when I say W2, that means buoyant force exerted by the liquid. When this buoyant force can be written as V1 rho. So W1 is written as m1g and W2, that is means the buoyant force. So buoyant force is given by V1 rho 2 g, right? So when I say buoyant force, force is denoted by this V1. Volume is V1 because that will be volume of this object, right? So what is the volume of this object is V1 and rho 2 is the density of the liquid and acceleration due to gravity. If I now cancel G and G, what we will get here? We will get here M1 greater than V1 rho 2. Now even if I divide this one V1 by rho 1, or this can be written as, or let me write clearly here in the next line. So here you see V1, if I divide here, then we will get V1 by M1 by V1. greater than rho 2. Mass by volume we know, that is density, right? So from here it is clear that is the density of immersing object, the object which we are immersing in the liquid, if its density is more than the density of the liquid, then object will sink inside it, right? So we have proved here rho 1 greater than rho 2. So this is the symbol of density. Rho 1 is the density of the object and rho 2 is the density of the liquid. Second condition we have when W1 is less than W2. So what is W1? That is the weight of the object, and W2 is the buoyant force exerted by the liquid. So W1 can be written as again M1G, right? W2 can be written as V1 rho 2 G. G and G will get cancelled. M1 V1 rho 2. If I divide, that is M1 by V1 greater than rho 2, or this can be written as rho 1 less than rho 2. So in this case, when an object is immersed, you see in the same diagram, the object when we are immersing in the liquid, if the density of W1, that means the weight of this object, is less than the upthrust exerted by the liquid in upward direction, then the object will float up, right? So we can say that an object is floating on the top surface of the liquid when the weight of the object is less than the buoyant force. Why an object is surfacing means it is floating on the surface here, because the density of that particular object is less than the density of the liquid, which we have proved here. Okay, so now third condition, that is the last condition here, we will see. So you need to write these notes in your exercise book, right? What is law of flotation, what are the two forces acting on an object, and what are the three conditions along with the diagram. So third condition, that is case 3, when W1 is equals to W2, right? So W1 equals to W2 means here when both the densities are same. So when both the densities are same here, if I consider this was the beaker and this was the liquid, then the object will sink below the surface of the liquid, right? Let us consider if you are immersing a thermocol in water, it has been seen that thermocol is floating just above the liquid. Why? Because the density of thermocol is less than the density of the liquid, so it is floating up. But if you see ice, some ice what we have means if you consider as ice cube, if you put in a glass of water, then you will find the ice cube is floating along the same surface of the liquid. So because both the densities are more or less same. Okay, I am not considering here the icebergs, big icebergs which we have seen in the film Titanic also. Due to that there was an accident and all you are aware of it. So in that case, ice few portion is being seen outside the surface of the liquid and a larger portion is inside here. Okay, so but generally in a practical experiment, if you see in your home, if you put an ice cube in a glass of water, you find both are floating in the same surface. In that case, both densities are same here. So what are the three conditions of principle of flotation here? W1 less than W2, W1 greater than W2, and W1 equals to W2. When the weight of an object is greater than the buoyant force, then it will sink inside. If the weight of the object is less than the buoyant force, then it will float on the top of the surface. And if both the densities are same, that is W1 equals to W2, both will float on the same surface. So this is the condition you see when weight of an object is greater than the weight of the liquid, or you see the buoyant force exerted by the liquid, the object is settled down on the vessel. So this is the condition here you see when the buoyant force exerted by the liquid is more than the weight of the object. Okay, so few portion of the object is outside the water and a few portion is inside the water. And when both the weights are same here, that means the weight exerted by the object vertically downwards is equal to the buoyant force which is exerting upward. When both are equal, in this case the body will float just inside the surface of the liquid. So in my previous class already I have explained what is apparent weight. That means when an object is immersed in a liquid, its weight is decreasing. So apparent weight is given by, you see, actual weight minus upthrust. If the upthrust is more, then you will feel yourself lighter, and if the upthrust, that means the force exerted by the liquid, is less, then you will find less difference. So that is why when we hold a stone inside the water, we find it is lighter, but the same stone when we carry on the air, we find it is heavier. So what are the conditions of flotation? Here you see the weight of the liquid displaced by the portion of the body below the liquid surface must be exactly equal to the weight of the floating liquid. Now it has been said that the object which you are immersing in the liquid, if that weight is equal to the displaced portion of the body below the liquid, then the object will float. That means the portion which is inside the water, if the same portion of the liquid is above, that means when both the weights are balanced here, so then only the object will float. Next we have the center of gravity of the body and the center of the buoyancy of the displaced liquid must lie in same vertical line. That means the force which is acting downward, that means the weight which is concentrated at the center of gravity which is acting downward, and the buoyant force which is acting at the same line, means they should be at same vertical line. So for this class only this much, so we'll meet soon in my next video. So till then you have to write these notes in your exercise book, okay, just the important terms and draw the diagram, okay, and in between I may conduct an interactive class session and you need to give me the update of your exercise book. I need to see whether you have writing all the answers, question answers in your exercise book or not, right? So till then, goodbye.